Okay, so we were doing integral from 1 to 9 of square root of x with 4 subintervals equal with. Okay. Okay, so what if we're doing our trapezoid rule. So it's always going to start with 1/2 because that's part of the rule. Now, what did we say delta x was, or the width of each of your rectangles? 2. Okay, well that's nice. All right, now the first, again, it's 1 time the first endpoint, the last endpoint, and then it's 2 times everything in between. Right? So we started with f of 1, right? So we're only going to do 1 of f of 1. Right? And then what would the next one be? Good. Plus 2 f of 5 plus 2 f of 7, and then 1 times f of 9. All right, so that's your trapezoid rule if every trapezoid is the same width, right? 1/2 times the width of each. First time, 1 time the first and the last one, 2 times everything in between. So, 1. F of 1 is 1 plus 2 radical 3, 2 radical 5, 2 radical 7, plus 3. Is everyone all right how I got those numbers? Makes sense? So the function is the square root of x, right? So you're plugging each of those numbers into there. So what do we got? 4 plus 2 radical 3, 2 radical 5, 2 radical 7. So that would be what? $17.227. What do you got? Okay. All right, so do it on your calculator now to get the exact answer. So that would be math 9. So you type in your function, comma, x, comma, your lower bound, comma, your upper bound. So math 9, square root of x. All right, so it's, again, it's always, if you have the newer one, it's pretty self-explanatory, but again, function, comma, x, comma, lower bound, comma, upper bound. So the exact area of that region would be 17 1/3. Sorry? Yeah, 9. Yep. All right. If you guys wanted to, you could also do it with the graph. So if you wanted to put in y1, the square root of x, and then change the window to be like 0 to 10. Too much. And then -1, 10. Right, so that's the function that we're looking at. We're only concerned about from here to there, right? So another way that you could figure out the area of that, right? So if you hit seconds and then trace, and if you go down to number 7, right, the integral of f of x dx, you're going to hit enter. Now it asks you for the lower limit, right? So where did we start? We started at x equals 1. So I'm going to type in 1. And then it asks you for your upper limit. So where did we stop? We stopped at 9. So it fills out for you that area, and it gives you the answer. So you can do it either way, whatever your so the square root of x in the y1. Right? Mm-hmm. Yep. Second trace number 7, 1, enter, 9. Number 7. That'll give you the integrate method. So either way is fine. I feel like the other way maybe is a little bit easier, but you know, if you guys are ever at a party and you want to show off to your friends, you know, it's always something you can do. Okay, so it says evaluate the definite integral of 2x from 0 to 4 geometrically as well as on the calculator. Okay, so they don't give us any intervals to do, correct? That's all right. We don't really need to. So since we've been talking about area, we can actually figure out the area that line will give me. All right, so if you have 2x and you're looking at it from 0 to 4. 1, 2, 3, 4. Now, 2x is just a linear line, right? If I plug in 4, I get 8, right? All right, so what I want to do is I want to look at the shape underneath that line, between that line and the x-axis. What kind of shape does that give me? Triangle, right? A triangle is something that we could figure out, right? So area would be 1/2 base times the height, right? The base in this case would be 4, and the height would be 8. So you have 1/2 times 4 times 8 would be 16. Right? So this is just another way that you could come up with a definite integral, is by using the shape of the function to come up with the answer. Now, if you do it on the calculator, do we get 16? Yep. So what is it? 2x comma x comma 0 comma 4. Right, so you get the same thing. So again, another, if you have something, I mean, 2x is pretty simple, right? So if you have something that's, you can, graph, I would definitely try and do that. All right, so we've been talking about all these regions, right, have all been above the x-axis, right? This region here is above the x-axis, right? That's not always going to be the case, right? Sometimes we're going to get regions that are going to be underneath the x-axis. So what do we do then? All right, so what this has been giving us, right, this integral going from a to b, is that it gives us the area from this point to that point, right? But if we have part of the region that's underneath the x-axis, it no longer gives us the area, because area cannot be negative, right? So this is A, and this is B, right? We'll call that C. All right, so if I take the integral, right, going from A to like C, right, this region here would be above the x-axis, correct? Right, so that's going to give me the area there, right, because it's above the x-axis, area is always positive, right? Now, when I do this piece here is underneath the x-axis, so now it no longer gives me the area, because this, when I do the integral of this, it's going to be negative, right? Area can't be negative, right? So we have to figure out a way, how can I change that? Right, so if this region here gives you a negative area, we want to make it the opposite, right? So any time you want to make something the opposite in math, what do you put in front of it? A negative, right? So if I were to do, say, the integral going from C to B of f of x, that would give me a negative answer. Right? Again, I do not want that, because area has to be, if they're asking for area, it has to be positive, right? So all I'm going to do is I'm going to slap on a negative out front. All right? So now when I do the region from going from this letter to this letter, right, it's going to give me a negative, but then I have that negative out front, which then will make it a positive. All right, so again, an integral, kind of have to imagine like an integral doesn't actually just give you area. It gives you, say you were walking along a path, it's like what you pick up as you go, what you accumulate as you go along, right? So you guys are, say you're working, right, over the summer, you get money coming in, right? But your bank account's not going to be just going up, right, the whole time. You're going to be spending spending on stuff, and money's going to be coming out as well, right? So, you know, imagine this is like the beginning of the summer, the end of the summer, right? This is going to give you how much money you've accumulated over that period of time, right? So whenever you work, you are gaining money, right? So that part of your integral would be above the x-axis, and then anytime you go out and spend money, that part will be underneath the x-axis. That's what you're losing, all right? And then if you add everything up at the end of the summer, that'll give you how much money you have left. All right, so if you look on the next page, when integrating from left to right, regions above the x-axis are positive, regions below are negative. All right, so if I do, say, the integral going from -5 to -2, right, -5 to -2, all of that is above the x-axis, right? So this part here is going to be positive, right? So I'm going to say this is, say we'll call this 12. I'm just making these up for example purposes. So if I do the integral from -5 to -2, right, and nothing else, it's going to give me an answer of -12, right? So say you've worked for 3 hours, you've gained $12, right? And then, did I say -12? I meant +12. Sorry. And then maybe now as I go from -2 to 3, all of that is underneath the x-axis, right? So what you've now gained, right, so part of this 12, you're going to be losing part of it as you go from -2 to 3 because it's below the x-axis. So maybe I'll call that, say, 7. Right? And then as I go from 3 to 5 again, I'm gaining more material. Right? So say 3 to 5 could be 6. Right? So if I were to ask you the answer going from -5 to 5, what would that be? So as you go from -5 to -2, you gained 12. From -2 to 3, you lost 7. And then from 3 to 5, you gained 6 back. So what would your answer be? 11, right? Okay. Now, is that 11? Does that tell you the area from -5 to 5? No, right? Because we have this chunk here that is underneath the x-axis. Okay, so it will not give you the area. Well, area has to be positive, right? So the area of this, say, was 12. The area of this is 7, and the area of that is 6. So if you add those 3 pieces up, you get what? Right. So that would be the area. But just the integral going from -5 to 5 would be 11. So what you accumulated going in that region would be just 11. Right? So -5 to 5 is 11. We'll say does not give us area. Since -3 to 2 is negative. Does that make sense? Yes, if you go from left to right, if you read it from left to right, anything underneath the x-axis will be, yes, negative. All right, so if you are now going from right to left, sometimes they will ask you right to left. All right, so now instead of going from -5 to 5, what I'm doing is I'm going from 5 to -5. So I'm working backwards. So if you go from right to left now, anything that is above, everything kind of switches. Everything that's above the x-axis will now be negative. Anything below will be positive. So if I say call that 12, 7, and 6, if I now do the integral from 5 to -5, what would I get? The -11? -11. They would give you that. Like that right here is your clue. Like I'm going from 5 to -5. So I'm like working backwards. It's just different ways they ask you questions. Right? So as I go from like 5 to 3, right, it's -6. From 3 to -2, that's +7. So then I'm at +1. And then from -2 to -5, I subtract another 12. Right? So you're back at -11. It's all depending on when you start and where you stop. Right? So we went from, on the top one, we went from left to right. So we started at -5 and stopped at +5. Bottom one, we're working backwards. So we started at 5 and then went back to -5. It all depends on the direction that you're going. Does that not make sense? Yeah, right. Yeah, right to left is like opposite, right? You would never read right to left. Right, right. Yeah, yeah. All right, so I get the same answer, right? Except one's positive and the other one is negative, right? So what I want to do is I want to try and see how can I make that one like the one before it, right? Right, I have to put a negative out front. So what I can do is I can take, this is going from, say, left to right. What I can do is I can switch my upper and my lower bounds and then put a negative out front, right? So if we said the integral from -5 to 5, what did we say that was? From the first one, 11, right? So what I can do is I can switch, if I switch that, right? Now I'm going from 5 to -5. And what did that give us? -11, right? What I want to do is I want to make them the same answer, though, right? So what I can do is I can attach on a negative out front. And now, if I take the answer here, that'll give me what? Positive 11, right? So you can do that when you are working with problems. If you want to kind of switch around your upper and your lower bounds, you can do that, but you just have to remember when you do that, you have to put out a negative out front. So we'll look like kind of later, you'll see like, say you have 2 to 5, and then right? So if I was interested in, say, taking those two integrals and putting them together to make one simple integral, right? Instead of having to do the integral twice, what I can do is I can rewrite this one, right? So instead of going from 3 to 5, I can flip it and make it go from 5 to 3, right? And then if I do it from 5 to 3, that plus sign will then become a minus, right? So you can have it, say, from 2 to 5 minus, say, 5 to 3. Right, and once what you can do is, since that this and this are the same, so the upper bound here and the lower bound here are the same, I can put them together and make one. So I can turn it into 2 to 3 of f of x dx. Kind of, yeah. So like you go from 2 to 5 and you grab some things, but then you go back from 5 to 3 and you lose some things. So this here would really be the same thing as just doing it from 2 to 3. Yeah, I mean, that's kind of where we're headed. But you want to make sure that your upper number here and your lower number here are the same. If they're not the same, then you can't push them together. All right, I kind of did that on the next page. Right, so if you have two regions and you're adding them together, if they upper here and lower here are the same, you can put them together, and it's the same thing as going from this bottom number to that top number. So it's all the same thing. All right, so write and evaluate the integral expression that gives the area of the region bounded by the graph and the x-axis from -3 to 3. All right, so what you guys should do is see if you can come up with the graph of that. So just draw it the best you can. If I plug in -1, what do I get? Do I get that? Okay. So and if I plug in 3, I get -1. Okay. They tell us that they're only interested in it from -3 to 3. So that because if you plug in -1 here, right? 2 minus -1 gives you 3. So like this overlaps that one. They like kind of fall on top of each other. All right, so this is less than -1, right, is 3, and then from 2 minus x would go from -1 to 3. All right, so I want to figure out the area. Oops, that's really of that region, right? So it's got to go along with the x-axis. All right, so we want to figure out the area. All right, so right off the bat, if they're looking at us from -3 to 3, and we're looking for the area, what would your first kind of integral expression be? Like, very simple. I kind of want to do like the whole thing. So just like negative 3 to 3 of f of x dx, right? That's what we're trying to find. Negative 3 to 3. All right, so we kind of have to use our area technique to kind of help us figure that out. So I want to kind of split it up into different parts, right? So we're going to find the area from here, so all of this plus this, right? So if I do the integral from negative 3 to 3, I have this little piece here that is underneath the x-axis, so that's going to take away from what my answer is. So I don't want to do that, right? So I kind of have to kind of figure them out separately so that I can find the area. All right, so if I draw kind of a line right here at negative 1, now I have a rectangle, right? Then here I have a triangle, and then here I also have a triangle, right? So the area of that rectangle would be what? 6, right? 2 times 3. 2 times 3. Now, what about the first triangle? What would that give you? So 1/2 of this. 1, 2, 3. So that's 3 over 2 times the height, which is 3, right? So 3 over 2 times 3 is 9 over 2. We okay with that? And then what about the last, like the little piece, the little rectangle or triangle here? One half, good. Okay. So you do the base is 1, right? So half of that would be a half times the height, which is just 1. So it's a half. Now, if I were to do just the integral from negative 3 to 3, what would that give me? It would be 6 plus 9 over 2 minus 1/2, right? So that would be 6 plus 9 over 2 minus 1 over 2, which would be, that would be 10, right? All right, so what I want to do is I want to kind of change that around so that it gives me the area. All right, so where's the first part that you hit negative area? 2, right? So if I take the integral going from negative 3 to 2, that should all be positive, right? So I have negative 3 to 2 of f of x. Now, if I do it from 2 to 3, that's going to give me a negative 1/2, right? So how would I have to change that so that I could make it positive? Minus, right, you could do 2 to 3. Right, what did you say, Dante? Right. All right, now, if we switch these, right, right? That'll go from 3 to 2, and then whenever you switch them, you have to put what out front? Negative, right? Since I already have a negative there, 2 negatives make it a positive. So you can go from 3 to 2 of f of x. All right, so we know from negative 3 to 2, that's going to give me what? 6 plus 9 over 2 is what? 10.5. And then if I do it from, now if you're working backwards, right? If you're going from now 3 to 2, instead of this being negative 1/2, it's now positive 1/2. So your final answer would be 11. So this here is the area. From negative 3 to 3. All right, so you got, just kind of pay attention to what they're asking. If they're looking for area or if they're looking for the integral, it's really two different things.